Thanks for having me. Um, so I noticed all of the previous talks were pretty high level. This is a bit more technical, so brace yourself. I wanted to talk to you about how LLMs change our posture regarding operating systems and how we could maybe build something new that is sovereign and that is good for the next generation of computers. And to do this, I just want to set a bit of context. So I've been a Linux guy for a long time, and we never had as much open source as right now. At the same time, I feel like we're more centralized than before. There's more vendor lock-in. So it's an interesting contradiction that we have. And last November, something changed for me, at least. It felt like LLMs were something interesting before, and now suddenly they feel like, oh, this is something useful, and I can reduce, instead of generating more randomness, it's actually converging towards useful code or something that I can use. And so how does it apply to operating systems? The other good news is actually OpenModel are tracking behind. So 3 to 6 months, you actually have models that you can run on your computer. And so something we discovered as well is with the models getting better, they're getting better at finding security issues in open source. And this kind of raises the question of what do we do with open source? How do we handle this if we want to stay on a free and open source ecosystem? And a last aspect, which I don't think anyone talked about yet, is we actually spend a lot of time talking to our LLMs. And I think this changes, like this is more of a society question of do we want to talk to each other, or do we want to have our agents talk to someone else's agents? And I think like as much as the advancements have happened right now, we haven't really solved this problem of how do we make it more social as an experiment. So how could this future operating system look like that would respect your privacy, that would integrate with local LLMs, has maybe a social multiplayer aspect to it, and it also kind of has more secure foundations so that when other LLMs come and kind of check your system, you're not getting corrupted. So we're grateful to Vitalik, who funded some of those efforts. It turns out he's interested in CROPS. This is his acronym. And what we wanted to do kind of overlapped really well with what he wants to do. So he's funding a little bit of this effort. So thanks, Vitalik. And so we've been building this for 7 weeks now. And this is what we have. We have a desktop. This is the desktop that you can install. And it integrates with, there's a chat application here that runs with your local LLMs. And this is all sandboxed, so it only has access to the things that you give it access to. You can also configure it with OpenRouter if you need a bit more speed. And so yeah, this looks like a normal chat LLM app. We also added voice support. So here, you should be able to understand what I'm saying. Yes. So this is still very early. demo effect. So it integrates with your email, calendar, contacts, Signal. You can also have like offline Wikipedia with you, so everything that you access is kind of contained, and every time you want to execute an action that would kind of result potentially in exfiltrating your data, permissions is asked. So it's always like consent driven. And then we developed a server version. So now you can actually have the same app and you can connect it to your server. And when you're on the go, now you can also connect with your phone and you can talk to both like all of the machines that you have connected. So this is the higher level. And then I want to talk to you now, it's getting a bit more technical. We're going to talk about Nix. So I've been a Nix user for 10 years now, and something special happened with these LLMs. It's like a special moment where Nix is a pretty niche technology. It allows you to compose software together and build larger systems up to a full operating system. And you do it through this language that is functional, and it's very geeky. One of the nice aspects of Nix is you can fully control your operating system. You can replace every part with something else. And now with LLMs, we found that you can actually ask the LLM to write the code to configure your machine. And this is something that I don't think we appreciate really well right now, because I think what happens is we still have agents, SSH into machines, and maybe configure things manually. Whereas with Nix, you can generate the code and then apply the code that you reviewed onto the machine. So now if you have your machine configuration as code, you can share it with your friends. You can, it provides good properties of isolation. And Nix is actually a very large ecosystem. We have more than 10,000, 100,000 packages. So it compares to other more traditional Linux distribution like Ubuntu, Debian, Red Hat. So most of the software that you would use on Linux, you would find it already packaged in Nix. So I talked a little bit about this higher level layer and the lower level layer. And I want to talk about the future. What are we going to work on after? So one of the aspects I mentioned before is I think we want to kind of explore how we can do multiplayer with those LLMs. We have some ideas of how we can connect. We can actually share applications, sandbox them, and only share that application with another machine, and actually share a computer, keyboard, and mouse. So you can maybe share your Claude agent with the other people and kind of talk together. We are also working with the Qubes team on an experiment where we're trying to replace the Linux kernel with Gnode OS. So we're going to put micro VMs on top, and that would provide like a more secure foundation for your operating system. And the end goal is to reduce the amount of code, basically, of your operating system. Another thing that's already built once, and I'm going to build a second time, is a fully automated packaging ecosystem. So whenever we have this number of security holes and a number of software being written that increases over time, we need actually the Linux distribution to be able to react to those changes quickly. And so one of the experiments is to actually fully LLMize the whole software supply chain and then add guardrails to make sure that nothing dangerous gets stuck in. And by the way, with the first experiment, I discovered it would cost 200K of tokens to rebuild the 100,000 packages that we have in Nix packages, give or take. Another thing we can build on top of Nix is a distributed app store. So instead of depending on Google or Apple, we can actually publish things on a peer-to-peer layer. And with the sandboxing techniques that we have, it's actually safe to run someone else's code on your machine, and you control what the application has access to. And then this is, I think, in 1 or 2 years, you should be able to draw applications on your screen, and then they get generated, and then you can share them with your friends. But that's, I don't want to make promise on that. It might take a bit of time. Yeah, so that's the vision. And we're a group of different people from different backgrounds. And if you want to help us out or hack on things, we're looking for first users, people that are a bit technical and that would like to try our operating system. So yeah, reach out to us, and I'm here. I'm happy to talk to you about our experiments. Thanks.
All right, before we head to lunch, we have time for one question. Yes?
Do you enforce that all peers are live, or like if some peers are not live, like where the data would leave?
So I guess your question is, what do we do with persistence? For example, if you start the session on one agent and you want to move it to the other machine?
Yeah, like multiplayer, in parallel, but for example, if one goes away, but you still want to have like this shared session to be ongoing.
Yeah, that's a good question. So right now it's very naive in the sense of the host, there's one host that hosts the data. Once we add the peer-to-peer layer, we can actually shift the data around, and that's going to be interesting.
Store this data separately.
That's still research.
All right, thank you again.